All right, so I have supply and demand of a gallon of something. In order to raise revenue, the government imposes a 2 per gallon tax on consumers. What is the new equilibrium market price and quantity after the tax? All right, so this is in equilibrium. Before the tax, quantity is 7, right? And price is 6. Now, the tax is going to be in the amount of $2. So I need to find the point where the difference between the demand and the supply curve is 2. And that's right here, almost. Okay. So what's the new quantity produced? It's 6, right? The new quantity is 6, and the new price? So that will be answer C. Right? 6 units, that's how much is the quantity. And the price is 7, so that's answer C. By how much does total surplus change from before to after the tax, assuming there is no negative externality to soda consumption? Okay. So if there were an externality, total surplus would actually be higher with the tax, right? Because the tax will be correcting for it. In this case, there's no negative externality. The government just imposes a tax. So by how much would total surplus change? Would total surplus go down or would it go up because of the tax? What happens to total surplus? It goes down, right? Because no negative externality. So total surplus would go down. This is basically the deadweight loss of tax. And the deadweight loss, we know, well, before the tax, total surplus was this whole triangle. After the tax, total surplus becomes the trapezoid. So the loss, right, the deadweight loss because of taxes is this area here. And the deadweight loss due to a tax, if you want to express it as a formula, that will be, well, the base of this triangle is just the amount of the tax, right? It's the difference between the demand and the supply. So it's the amount of the tax times, and then this, the height is basically the difference between the quantity in equilibrium and the quantity after the tax is imposed. Right? So how much quantity was lost? So it's the quantity in equilibrium minus the quantity after the tax, and that divided by 2, since it's a triangle. All right. Well, the tax is $2, and the quantity in equilibrium was 7. After the tax, it was 6. So I've lost 1 unit. Divided by 2, it's $1. So the deadweight loss is due to the tax is $1, and that's answer B. All right. How much of the tax is borne by consumers? Right, so the easiest way to do this is just, you know what the price was before the tax? It was 6. Now consumers pay 7, so they pay $1 more. And before the tax, the price was 6. Now producers get 5-ish here, so they pay the other $1. So it's kind of split in half here. Okay? So how much of the soda tax is borne by consumers? $1 of it. Or it could have been, what is the tax incidence on consumers? You know, it's about 50%. Well, 50% will be, yeah. Right, so they seem to share equally in the tax in this example. All right, so consumer advocates complain that the tax should be placed on suppliers and not consumers, so that suppliers and not consumers bear more of the tax. Is that true? No. It doesn't matter who ends up paying it. It's always going to be whatever the tax burden, the tax incidence is. It's constant, whether you charge suppliers or buyers the tax. So that's not going to be true. they contend that the deadweight loss would be less if the tax is placed on suppliers because the demand for soda is inelastic. All right, so which of the following statements is correct? And the statements are whether consumer advocates are correct about either of those two claims. Here, when I found the deadweight loss, all right, is the deadweight, right, that's, I'm trying to explain that, but the deadweight loss is going to be the same. Again, doesn't matter who you tax. It does depend on the elasticities, but it doesn't depend on who pays the tax. Because even if I charge buyers, the relative elasticities of those curves are not going to change, right? The tax payment happens after the market, basically. So it's true that the deadweight loss depends on the relative elasticities of demand versus supply, but who pays the tax is not going to change that. Right? So the deadweight loss is the amount of the tax. It's not the amount of the tax charged to buyers or the amount of the tax charged to sellers. Right? It's just the amount of the tax in total. So both of the statements are not correct. And this would be C, I think. Consumer advocates are wrong about both the burden of the tax and the deadweight loss. Okay, so now assume that soda consumption imposes a $2 negative externality because it causes obesity. If this is true, then a $2 tax on soda would actually increase total surplus. Is that correct? Let's reason through it. So we saw that there's a deadweight loss, right? But the deadweight loss was under the assumption that there's no externality. Now there is an externality of $2. Right? Is that good or bad? When they impose a tax of $2, is that good or bad? That's good. So total surplus? Total surplus decreasing is not a good thing. Increases. Right? This is like that example where we had, if you remember, the total surplus was 900, but then there was an externality that they did not account for. Right? So the total surplus, when you account for the externality, is going to be lower than the total surplus once you correct for it. Right? Because there's overproduction here. We're producing more. When this market produces 7, they're producing more than they should. The socially optimal production would be 6. All right. So a $2 tax on soda causes a deadweight loss. This is only true when there's no externality. They would internalize the externality, but that gain would be offset by the deadweight loss. That's not true. The gain will be actually higher than the deadweight loss. And none of the above, well, it's A. All right? No, because I don't know this intercept. But if I assume the intercept is 0, all right, so total surplus without intervention, right? This is 15, that side, times the quantity, times 7, divided by 2, right? Minus, because I have an externality that I'm not accounting for, 14. All right, now when I impose the tax, right, what happens is there's a shift. It's like a shift in the supply, right? So now it's $2, so I'm here somewhere. All right. Now the total surplus is 15 minus 2 times 6 now, right? Because that's the optimal quantity, divided by 2. But no externality anymore. I've taken care of that. It would increase, yeah. It will be higher. Yeah, yeah. All right. Which of the following would cause the demand curve to shift from demand C to demand A in the market for Honda Accords? So demand C is this one, the last one. What would cause a shift from here to there? I need a shift in the demand curve. Would an increase in the price of Honda Accords cause that? Right, this is the market for Honda. If the price goes up, would the demand curve shift? No. Right. Changes in price of this particular good are causing movements along the curve, right? Not shifts in the curve. A decrease in the price of Toyota Camrys, right? So what do you think Toyota is relative to Honda? They're substitutes, right? So if there's a decrease in the price of Toyotas, are people going to buy more or less Toyotas? Toyotas. More. And if they buy more Toyotas, are they going to buy more or less Hondas? Less, right? And that could cause the shift, right? So there's a decrease in demand. So that's true. An increase in consumer income, well, that will be the other way around, right? It will be shifting to the right.
Really bad car and it's an inferior good.
True. I don't know if that's true, though.
I got confused. I thought Honda might be a bad car.
Oh, you did? No. Well, inferior
Like
goods.
Ford Taurus or something on there, make it like.
No, inferior goods are much worse than that. This is kind of. You wouldn't buy, if it's a bad car, what it's saying is that if you have less money, you buy more of it. And that doesn't really, just the price of it, right, doesn't really make that much sense to be. But you're right, if it were an inferior, that would be the case. Increase in the wages of Toyota workers. So now we're back to Toyota. Let's draw the Toyota market. If there's increase in wages, what does that do? Does it change demand for Toyota? It changes supply, and it decreases supply, right? Because now it's more expensive to produce Toyotas. And if there's a decrease in supply, what happens to quantity and price?
The price increases.
Right, price goes up, quantity decreases.
So you buy more Hondas.
So we would buy more Hondas, exactly. All right? Almost done. It's B. If the demand for donuts is elastic, a decrease in the price of donuts, would it decrease total revenue, increase it, or not change it? All right. So total revenue, I know is price times quantity, right? I also know that when demand is elastic, the elasticity is change in quantity divided by change of price, right? Change in price. So if it's elastic, that means it's more than 1. What that means is also that change in quantity is higher than the change in price in absolute terms, all right? That's when demand is elastic. Now, what will happen to total revenue? Well, total revenue is price times quantity. Now, what happened? The change here is that there's a decrease in price, right? So price went down, which is a bad thing for total revenue. But by price going down, what happens to quantity? Goes up. So price went down and quantity went up. One is good. Quantity going up is good for total revenue, but price going down is bad for total revenue.
But you have more quantity than
Exactly, but I know that the elastic demand gives me more of the good compared to the bad, right? So the increase in quantity is going to be more than enough to compensate for the decrease in price, right? Does that make sense? So total revenue is increasing, which is A. All right, so suppose researchers discover a new vitamin that increases the milk production of cows. If the demand is relatively inelastic, then the discovery will do what?
It's inelastic and the price is higher than the quantity.
Right, so what we have, all right, so let's do this again. total revenue we know is this. Now we have inelastic demand though, right? And then we have that the change in quantity would be less than the change in price now. So the question is again, what's the effect on total revenue? But the total revenue effect is going to depend on whether there's an increase or decrease in price. And there's no clear way that's identified in this question, so I need to figure it out. Right? And let's figure it out by just looking at supply and demand. All right, so this is the market for milk. Okay? A new vitamin that increases the milk production of dairy cows. What's going to happen? Shift, movement, what's going on here?
Supply.
Shifting supply, higher supply now, right? So a shift to the right. And if the supply curve shifts, increases, what happens to the price? All right, so now the price is going to go down. Again, quantity goes up. This is bad for total revenue. This is good for total revenue. But now I have inelastic supply.
So the price is.
So the change in price is more than the change in quantity. So the total revenue in this case is going to go down. Does that make sense?
So the price goes down.
Yeah, because there's more
And the
supply.
revenue both go down?
Sorry?
The price and revenue both go down?
In this case, yeah. So B. All right, this is just theoretical. If the price of walnuts rises, many people would switch from consuming walnuts to consuming pecans. But if the price of salt increases, people would have difficulty purchasing something to use instead. Right? That makes sense. These examples illustrate the importance of what?
Necessity versus luxury.
All right, let's look at so the time horizon in determining the price elasticity of demand. Is that true? Are those examples of that?
We're not looking at time, so.
There's no time component here, right? The definition of a market in determining the price elasticity of demand. These are from first midterm questions. All right, so the time horizon basically means that elasticity is higher in the long run. The definition of a market means that when you define the market as markers, what is this? Expo markers versus school supplies, right? The elasticity of school supplies would be much lower, right? Because there's not a lot to substitute this market with. A necessity versus a luxury in determining the price elasticity of demand.
I mean, the salt is a necessity. 'Cause you can't
Why?
substitute
Some
it.
people don't eat salt.
Oh, you die. You need salt. Right, but you can live with either like walnuts or pecans or whatever.
Well, the idea here is a bit different than that. It's the availability of close substitutes, right? Because it say that if walnuts increase in price, then you can switch to something else, right? There's some alternative to that. But if the price of salt increases, they will have difficulty purchasing something else, right? And that difficulty finding something else is just the availability of substitutes. Yeah. So it's A. All right, here have representative consumers' willingness to pay for a six-pack of beer. Assume the supply of beer is perfectly elastic. What does that mean? What is the supply curve? Horizontal, right? Perfectly elastic. All right, so that being said, this is how many packs they're willing to buy at each price, all right? If in the year 2015 the cost per pack was $7, how many packs they're gonna buy and what's the consumer surplus? All right, so at $7 they're gonna buy the first one, yeah, the second one, Third one?
Yes.
This one?
Oh.
No, that's it. So they're gonna buy 3 packs, right? So this is basically supply and demand, right? So the demand is decreasing. This is for 1, there's 15, then 2 would be 10, 8, 6, and 5, but supply is at 7, and it's horizontal, so it's right there. Right, so they're gonna buy 3, and what's consumer surplus? Well, they're gonna get, if the price is, so the price is 7, right? For each pack. So consumer surplus would be, for the first pack, 15 minus 7, or 8. The second pack, 3, and the last one, 1. Right, so consumer surplus is how much satisfaction you get compared to the price that you pay. This was like the tree problem that we had. Right? So they get 15, they were willing to give 15, so that's how much satisfaction it gives them. They only had to pay 7, so from the first pack they get 8 in terms of surplus, and then the total surplus would be 12, and the consumption would be 3. So it's B. Right? Now assume that there is external cost of drinking beer that is $2 per pack. Right? So there's externality. If New York imposes a tax per pack that internalizes the externality, so they impose a tax of $2, the total surplus per person in New York before the tax is something, and the total surplus per person after the tax. All right. So no tax.
The first one is 12 because we already found.
No, because the first one said that there's no externality.
Oh, okay.
Right? So the total surplus in the with no externality in the first case was 12. We just found that. That's the sum of those two. And there's no producer surplus here, right? Because supply is horizontal. So there's nothing between the price and the supply curve, which is by definition producer surplus. So producers get 0. Everything is consumer surplus. So before the tax, we know that total consumer surplus was 12, but we also know that they suffer without realizing it, right? And they suffer with, what is it, $2 per pack. There was 3 packs sold, right? So there's the externality cost is 6. So total surplus before the tax, right, is $6. Now after the tax, what happens is, where is it? All right. So after the tax, the tax is going to shift the supply curve by 2. Right? That's what it does. But the supply curve is horizontal. Right? So instead of being at 7 here, now it's going to be at 9, which is over there. Right? At 9, how many packs do I buy?
3.
Do I? At the price of 9?
2.
2, right? Only this guy and this guy are going to buy anything. The third pack is no longer economically viable, so I'm not going to buy that one. And what's the surplus then? Well, the price is now 9, so the first pack gives me a surplus of
6.
and the second a surplus of
1.
so the total surplus is 7, which is B. Right? All right, let's try this. All right, so this is before the tax, and then after the tax, I have price after tax is 9, right? So it's going to be 9 for everyone, but I'm only going to buy 2 of them now, and consumer surplus would be 6 and 1 in total 7. Okay, and here I also lost 2 times 3, right? Because there's an externality of $2, and I sold 3 packs. All right, so answer B. where did I get 7 from is the question. I got 7 because after the tax, before the tax the price was 7, right? There's a tax of $2. So the price is now 9. At the price of 9, 2 people buy. The benefit to the first guy is 6, and the benefit to the second guy is 1. 6 and 1 is 7. Sorry? Can you speak up? Where did they get this 6? Well, I know the total surplus is 12 without any government intervention. But when that happens, there's also external cost, which is externality, of $2 per pack. When the government doesn't interfere, people think that they're getting 12, right? But what they're not realizing that they're losing 2 per pack. And 2 times 3 packs being sold is 6. So the cost of the externality is 6. And if people get 12 and lose 6, then the net is 6. Okay. All right, I think this is the final one. All right, so there's average variable cost of 1. And average total cost is 3 when quantity is 500 units. What is total fixed cost? So this is exactly what we had with that graph, right, when we had to look at the difference, but we have the numbers here. So if average total cost is 3 and average variable cost is 1, what can you tell me about fixed costs? Average fixed is 2, right? So average fixed cost equals average total cost minus average variable cost. So average fixed cost when quantity is 500 would be 2. But I'm asked about total fixed cost. And what would that be? 1,000, yeah. Right, then that will be quantity times average fixed, and that will be 8,000, which is C. Questions?
Can you do that last step again? I cannot.
Can I do the last step again? If I have average fixed cost of 2, when the quantity is 500,
Right.
average fixed is fixed per unit, right? Yeah. And that's it. All right, guys, good luck on the midterm.